All right, now we're getting to the final deposit of creatures on the Earth by the worldwide flood. It's in the highest rock strata, the evolutionary rock strata, the imaginary one in the textbooks, but not well corroborated in real life. And that was the mammals, more complex, or water. Things deposit in water based on sphericity, density, and specific gravity. So mammals, usually larger, get a chance to go up higher mountains, the water caught up with them, and they drowned later. So they're going to be in the later strata, fossils. Forget the passage of time. And because they're amorphous in shape and not spherical like small shell animals or microscopic ones, they're going to be also deposited later. So let's take a look at K35 again and look for the final flood deposit, mammal fossils. The so-called Tertiary period is popularly known as the age of mammals because of the large numbers of mammalian fossils found in these strata. However, as with the so-called Paleozoic and Mesozoic eras, the divisions of the Tertiary and stratigraphy are based primarily on marine deposits and marine organisms. The basic method of subdivision was established in a later, rather remarkable manner. Sir Charles Lyell first divided the Tertiary into Eocene, Miocene, and Pliocene on the basis of percentages of living species represented in each series, there being very few in the earliest and a very large percentage in the later. Later, the Oligocene was added by combining some of the uppermost Eocene with some of the lowermost. They can't make up their mind. They keep changing things around. The still later Paleocene is used by some geologists to represent a separate epoch of the Cenozoic, and by others to indicate the earliest part of the whole so-called Eocene epoch. Wow, that sounds complicated. How about water doing it? Because it's not consistent when you're looking at reality. William J. Miller, An Introduction to Historical Geography. Thus, the original divisions of the presumably most recent deposits were based squarely upon what amounts to the assumption of organic evolution. The chief index fossils of the Tertiary are the marine protozoa known as foraminifera, which occur in almost innumerable species and have been found in rock and strata all the way from the earliest Paleozoic and still exist in abundance in the present oceans. Certain species of these small-shelled animals are believed to have been rather universally distributed geographically in rather limited zones stratigraphically, which lends them an apparent validity as index fossils. Actual correlations, however, are usually made only within the range of a particular oil field or some such limited area. Other than that, not a lot of corroboration. In their discussion of index fossils, the evolutionists von Engelen and Castor indicate the importance to the evolution model which they have attributed to foraminifera for identification purposes in these rocks. So they got to make up this stuff. In the most recent Mesozoic, especially the Cenozoic rocks, great dependence by evolutionists is modernly placed on the foraminiferal microscopic single-cell forms in almost innumerable species, which, like the graptolites, microscopic-sized shelled animals, were free-floating, and evolutionists maintained experienced rapid evolutionary changes. How about they just went all the way down near the bottom because of sphericity, density, and specific density and their shape. Their minute shells, popularly identified, serve accordingly as index fossils to beds of only limited thickness. Wow. Recent studies, however, have cast grave doubt upon the validity of foraminiferal dating, based as it is upon the different shell forms of the innumerable species of these small animals. It seems now that the most gross differences in shell form can be produced by members of any one species, and thus do not show either evolution or necessary differences in chronology at all. only the possibility of tremendous variation within each species. Dr. Langenheim, University of California, Museum, Paleontology. Inasmuch as fossil foraminifera are of preeminent economic importance, the work of Arnold, with Allogrammia laticularis, has a special interest to paleontologists. Arnold has made a complete study of the life history of these living foraminifera and have discovered, among other things, great morphologic variation within laboratory cultures. Inasmuch as these forms mimic most of the basic plans of foraminifera and test morphology, it must be deduced that specific and generic concepts based on shell shape, which include all fossil foraminifera, are based on insecure biologic criteria, unsubstantiated, i.e. the evolutionists are wrong when they maintain that a different shell design constitutes another new species rather than a variation within that same species. Any given body form of chamber arrangement apparently must be potentially derivative from almost any ancestral type. This, of course, is of fundamental importance and indicates that a critical reevaluation of foraminiferan micropaleontology is in order. You're not consistent, better revise yourself. In other words, if we understand the implications of these studies correctly, any single species of foraminifera can yield tests essentially identical with those of any other species. Perhaps instead of the innumerable species of foraminifera, there is only one. Or in truth, only a few species with tremendous variation in characteristics such as shell types, as author Morris goes on to clarify. Of course, this is an overstatement of there being only one species, overstated in order to bring home the truth. But the general implication of evolutionary variation within a species seems valid. But what about the apparently well worked out and widely applicable techniques of micropaleontological dating based on foraminifera? It seems now that the well-defined faunal zones do not actually represent evolutionary changes, but nevertheless the zones are still there. The answer apparently is that these zones, as we have seen contending all along, we've been contending this all along, are due strictly to the hydrodynamic sorting action of the floodwaters and sediments in which they were deposited. More spherical shell goes down first. The original method of subdivision of the tertiary, that of percentages of living and extinct organisms, especially mollusks, are worked out by Lyell on the basis of the fossils found in the Paris Basin, is of course no longer considered definitive, but the basic terminology and division still persist. Why? The Paleocene, Eocene, and Oligocene strata are now identified mainly as associated with the large foraminifera known as nummulites and are no longer so predominant. It is significant that the tertiary deposits are usually found in more or less isolated patches rather than in great continuous sheets, so often is true of the Paleozoic and Mesozoic beds. There are notable exceptions, however, sometimes occurring in great geosynclines. It is likely that the tertiary deposits represented, in most cases, the later stages of the deluge activities, and they are usually found either on or near the surface of superimposed over Mesozoic beds. They are notable exceptions, however, sometimes occurring in great geosynclines. It is likely that the tertiary deposits represent in most cases the later stages of the deluge activities, as they are usually found either on or near the surface and superimposed over Mesozoic and or Paleozoic strata. However, it must be recognized that in some instances tertiary strata are found lying directly on basement rocks and sometimes found in as hard and crystalline a state as any of the presumably more ancient rock systems, and even are found lying beneath those supposedly older rocks in the case of the so-called thrust faults. In these cases, they are classified as tertiary primarily because of the more modern fossil assemblages found in them, but most likely represent either areas where these particular groups of organisms happened to be deposited earlier in the flood chronology, and they were at other localities, or else were redeposited there after either earlier deposits at the sites have been removed by some of the later periods of erosion during the flood. In the more typical cases, the tertiary rocks must represent some later stage in the deluge phenomenon. the details of which remain to be worked out. Lots of water over the planet Earth goes back and forth and back and forth. Huge, catastrophic, instantaneous changes. So you get stuff that looks different than it should be because it's the water that did it, not evolutionary charts that don't exist in real life. Fossil mammals, however, are not considered the chief indicators of the various stages of the Tertiary, despite popular textbook claims as to the worldwide provenance of marine index fossils. This is noted by the expert stratigrapher Gignaud. I think I probably pronounced it that way. Mammals are much more independent of local conditions than marine animals. They are also valuable for establishing correlations between widely separated basins for the species, and even the genera succeed each other in rapid succession. In the Nummulitic and elsewhere in the Tertiary, the mammalian faunas provide the only truly exact criterion for the distinction of stages. Maurice Gignaud, Stratigraphic Geology, says Gignaud is primarily interested in European stratigraphy, but he points out the rather remarkable procedure by which the European and American tertiary deposits have been correlated. There's my little arrow. Okay. Didn't bring my mouse with me. All these American Central States formations are sometimes extremely rich in mammalian bones, so that a scale of mammalian faunas can be established, absolutely independent of the American marine faunas. But this scale can be paralleled with the European mammalian faunas, and in that way with our marine stages, the latter being correlated with the marine fauna of the New World. It is evident that American stratigraphers can thus correlate with their continental faunas and their marine stages, a curious example of a singularly independent method of correlation. It must be surmised from the above, however, that these mammalian deposits are precisely identified and correlated on this worldwide basis. Notice, moreover, that the chronology of mammalian faunas, like that based on marine faunas, is valuable only within certain geographic limits. The foregoing recital of past and present criteria for subdividing the tertiary area seems to illustrate quite clearly our contention that the orthodox concepts of historical geology are almost entirely subjective in character, based squarely on the assumption of the fact of organic evolution, which is no fact at all. The variously correlated stages and even epochs are not at all based on the evidence of physiographic superposition, but rather on the paleontologic contents of the deposits, interpreted almost entirely in terms of assumed evolutionary development. It is significant that the most important paleontologic evidences of evolution are found in the tertiary strata. One need only mention such famous phylogenetic series as those of the horse and of the elephant to illustrate this fact. As in the case of the dinosaurs of the Mesozoic, so here the main feature of these presumed evolutionary series is that of an increase in size in the course of the ages. This phenomena of evolutionary size increase has been considered to be so universal that it has been called Cope's law. Yet, as the paleontologist Simpson says, increase in body size is very common, a stock example being the change from Eohippus to the modern horse. The phenomena is perhaps sufficiently usual to be a rule, but the rule has many exceptions. Even in the horse family, several evolving lines become smaller rather than larger. The apparent extent of this rule has been exaggerated by students who thought it absolute and who insisted that because an earlier animal was larger than a later relative, therefore it was not ancestral to the latter. Wow. Whatever may be the actual field evidence of increasing size with increasing elevation in the strata, they can once again be most easily explained in terms of greater mobility of the larger, stronger animals, and therefore their generally greater ability to retreat from the rising floodwaters and to escape being caught in the swollen streams rushing downward from the hills. There would be many exceptions to this, of course, and that is just what the strata tend to show, according to Simpson. More commonly, however, the various animals in the series, and even in the classic horse series, contains only a relatively small number of distinct forms with little indication of any sort of gradual change